Okay, we're going to have a look at some basic ionic bonding, and the example we're going to look at is sodium bonding with chlorine. Sodium here is a metal and chlorine here is a non-metal. Metal and non-metals usually form ionic bonding. Let's remind ourselves of the sodium atom structure, but I'm only going to include the electronic structure for the outer shell. There it is. How do I know I've got it right? I know because sodium is in group 1, and you can see here it's got one electron in its outer shell. Let's have a look at chlorine. Here it is, and again I know chlorine's correct because chlorine is in group 7, and if you count up those electrons, it's got 7 electrons in its outer shell. The basic premise behind ionic bonding is that atoms wants to have a full outer shell. If you look here, for sodium, sodium's outer shell has only got one electron. To get a full outer shell, it can either lose that electron, or it could gain 1, 2, 3, 4, 5, 6, 7 more electrons to get a full outer shell here. If it loses this one, the next one inside becomes the full outer shell. Which is the easiest for it to do? To lose 1 or gain 7, of course it's to lose 1. So sodium ends up looking like this, with no electrons in its outer shell, or the next shell becomes its outer shell, the next shell in, so it's got 8 electrons, but we ignore that. And then if you have a look at the chlorine, chlorine looks like this. 1, 2, 3, 4, 5, 6, 7 electrons, and it's gained an extra electron. There it is. The next thing that obviously springs to mind is, where does chlorine get this electron from? If sodium happens to be around, sodium gives its electron away, chlorine wants an electron, they both help each other out, and that electron there goes here. So the electron that was here has gone here. We're not quite finished yet because we need to look at protons, neutrons and electrons. You'll remember that sodium started off with, as an atom, 11 protons, 11 electrons and 12 neutrons, and chlorine started off with 17 protons, 17 electrons and 18.5 neutrons. Don't worry so much about the 0.5 for the moment. So when sodium has lost this electron here, that number goes from 11 down to 10. And when chlorine gains an electron, that 17 goes to 18. That now means that when sodium was an atom, when it had equal numbers of protons and electrons, it had 11 positive charges and 11 negative charges, overall it was neutral. But once it's lost an electron, it's lost a negative charge, so the protons, the positive charges, outnumber the negative charges by 1. So sodium becomes a +1 ion. And we usually put it in square brackets. Chlorine, on the other hand, started off, started off with 17 protons and 17 electrons, an equal number. So it was neutral. What it's now done is it's gained an extra electron here. If it's gained an extra electron, it's gained a negative charge. So what's happened is our chlorine has gained a negative charge. So what we've got here is a charged particle, otherwise called an ion. An ion is a charged particle. So now we've got a sodium ion here, sodium +1 ion, and a chloride -1 ion. The ionic bond is not the transfer of the electron from here to here. That's quite a common mistake. The ionic bond comes from this particle here, this charged particle, being attracted to this charged particle. That's the ionic bond, and that's the basics of ionic bonding.